the Discovery has blinking side lights here and here on the two edges. And they blink white. And for purposes of what we're going to do, doesn't matter, you can choose what color, or to use white or use a color. I, as a throwback to the TOS Enterprise, like doing a red and green blinking side light. But as you'll see, it doesn't matter. The electronics are the same, and then you just choose what you want to insert there. But anyway, this video will be about one way of getting that effect. So let's go look at my TOS Enterprise at what the effect looks like. Here's a sample of the side lights on my TOS Enterprise. And these are off of a control board by Tenna Controls. And you see it's got kind of the classic red and green. Red for the port, green for the starboard color that the TOS Enterprise had, with kind of a slow flash. There's a number of ways to get this look. Probably the most simple one is you can get these blink/flash SMDs pre-wired from HDA Model Works. This particular one is 0606. I think that's the smallest size. You can get a green one and a red one and use that. Here's an example where I did that. But these were wired separately, and as you can see, they pretty quickly get out of sync, which is an okay look. I prefer that they would blink together, and also I would prefer a slower blink speed. This one's a bit fast for my taste. But let's stay with this technique for a bit, because there is a way that you can wire these together and get them to blink in sequence. The key to this technique is you take your blink flash LED, and it's kind of your master. And so here is the positive power, right currently at 9 volts. These are wired for 9 to 12 volts. And it runs to the positive of this green blinking LED, which we'll call our master. Then the negative runs to the positive of a non-blinking, in this case is just another SMD. I just pulled a purple one. This is not blinking, it's a regular one. And then the negative from the regular one running to the negative power. So you've got the positive power running to your blinking LED, the negative of the blinking running to the, just connecting, or obviously you would solder this. I've just set this up so you can see it. Soldered to here, to the positive, resistor positive of the non-blinking LED, SMD, and then it's negative onto the negative of the power, and as you can see here, they're blinking in sync. So this one is the regular blinking one. It acts as a master, and it's making its slave blink in sync. So you could solder in a red regular SMD here, and that way you get them to blink in sync. They still are blinking a little fast for my taste for this particular project, but I could see where this could be very handy for a number of projects, and it's very simple. But having said that, we'll get into a little bit more complicated board controlled setup for these side lights. Just for grins, I ran a quick experiment to see if 2 blinking LEDs with just a regular LED between them might sync up. and the short answer is no. They do, like right now you can see they go in sync, but they will go off sync here. I was just wondering if on my other model I could just break in and stick an LED between the two and have those actually flash in sync. And they do sync for a while, but then here now you can see they start going off on their own tangent, which I kind of thought is what they would do, but I just thought it's worth checking. So we'll move on to building our flashing board, where these two lights, which will then be red and green, or if you want to be true to the Discovery, they can just both be white, but they will flash in sync. Take a screenshot or a picture of this paper I have in front here, and this will be your kind of guidebook or map to what we're going to do. Here's the schematic for those of you who are used to using schematics. I've shot a copy of this PC board that we're going to use, and I've labeled everything we're going to place in here. There's a little chart here, color-coded chart, tells you what goes where. The parts are, of course, the board, what's known as a 555 timer, integrated chip timer, and these come either separate, and I'll talk about where you can get all these parts here in a bit. This is by TI, Texas Instruments. This is the actual 555 timer. This is what's called an IC socket, which is optional. You can, the IC socket just gets soldered into the board, and then the chip just goes into the socket itself. And we'll get into more detail on whether to use the socket or not use a socket. I haven't quite decided here. I would tell you in my prototype I did not use it. The con is it's one more thing between your connections, and the actual chip. The pro is you're soldering here, so you're not. This is a rather delicate chip, and so you're not messing around with heating up its little legs. Or if it fails at some point, you can just get another one and replace it right in there. You can buy these separately, or they come in packs together. So you've got your 555 timer chip, and then you've got 3 resistors for this project. A 470 ohm resistor, a 470K, or a 470,000 resistor. And important, note the difference. It's not the 470 ohm, it's 470,000 ohm resistor, 100,000 ohm resistor, and then a 270 ohm resistor. And we'll talk here in a minute a little bit more about the resistors. Then a capacitor. So I've experimented with different capacitors, and I found that this one, 4.7, gives me the timing that I like on the on and off. And then, of course, you'll need your LEDs, which we'll talk about later. I'll probably use this one kind of as a test, but obviously we'll have the SMDs actually wired in the end. And then power comes from a 9-volt battery. So again, hopefully by now you've done it, but take a picture or a screenshot of this setup here because it'll be really helpful for you when you do this project. Here I've mocked up what we're going to build on what's called a breadboard. If you're not familiar with breadboards, they're great for mocking up electronics. Everything just fits right into these little holes, and it has copper that joins each row, running in this case north to south. so that everything on a particular row is making contact with everything else on that row. Then of course there's a break here in the middle and a duplicate side on the other side. And so you see here is our 555 chip down here, and of course we'll get into more detail on this, but you see the little cross jumper wires there, the resistors, here's our capacitor. Just for ease, I've inserted one of these screw down terminals and that's what I've inserted the LED in. And as you can see, the positive goes in this row here, the negative in this row here. And so let's insert, and you can see I've got a 9-volt battery here, so let's insert our negative. Whoop. Doesn't want to go in there. There we go. I think. Yep, got him. Okay, make sure we can see it on camera. It's kind of toward the bottom. Let's scoot this guy up a little bit. Bingo. Okay, so you can see the effect we're looking for. Kind of a slow on and off blink or flash. I guess blink. Flash sounds too fast. I'm looking for a slow blink. So we've mocked this up on the board, and I would tell you I'm very bad at spatial relations. So what I did is I just got a pack off of Amazon of PCB boards that basically mimic the breadboard, so that I can just take what I've done here and knock it right off verbatim or exactly onto the actual PCB board. As you can see on the back side of this, actually that's a good view of what the bottom of the bread, or what the inside of the breadboard looks like. You can see we just got rows of copper, so that anything on that row is connected to something else on that row. So that's the logic, as it were, in my choosing this particular breadboard, which I got a pack of these off of Amazon. And if you've got better spatial relations than I do, then you can take the schematic and probably get it even on a smaller board. But this board is pretty tiny anyway, and I'll probably end up using it too to power up the rest of the ship. So yeah, so that's the breadboard. Not the breadboard, sorry, the PCB board that we will be using that will mimic what we've already mocked up on the breadboard. The 555 timer chip has been around forever. It was invented back around 1970 by a gentleman named Hans Kamenzind, who is no longer with us, and it is used extensively. I just got this pack from Amazon, but it's Texas Instruments, pack of 12 of these 555 or 555 timer chips. And again, here's the actual chip. Here's the little socket that you can use or not use depending on the circumstances. Here's a diagram of what each leg of the timer chip does, and for our purposes it's not really that important to know what each leg does. I'm just basically a monkey connecting points to points, but what is important to note for our purposes is this little indentation in the chip. And I don't know if you can see it on the video, but but each chip has a little indentation that looks just like this diagram here. And so with that facing upwards, the legs of the chip are numbered 1, 2, 3, 4 going down the left side, then it cuts over to the right side, and from the bottom 5, 6, 7, 8 working its way to the top. As you can see, the negative power goes to the number 1 peg or leg, The positive power goes to the number 8 peg or leg. So again, for our purposes, the importance is look at your chip closely, find where this indentation is, and that way you know how to position your chip properly on the board. I've switched to my macro lens so you can see here the indentation on the actual chip and the indentation on the socket. And by the way, I kept calling these little legs, I think whatever I called them, legs or I can't remember. But anyway, they're properly referred to as pins. These are pins 1 through 4 and then 5 through 8. And I'm not going to end up using the socket personally for this one, but if you choose to use the socket, the pin just pushes right into the socket, and you remember line up those 2 indentations, and you'll be set to go. Let's talk a little bit about resistors. They, in essence, LED lighting can take usually somewhere between about 2.5 to 3 volts. You get much more over 3.5 volts, and you get, when you power it up, you get a bright flash and smoke. you blow your LED. Certainly at 9 volts or 12 volts, they can't take that. It's almost instantaneous. If you power it up at 9 or 12 volts, you'll get a quick millisecond of brightness and then smoke and a little bit of a smell and a dead LED. The resistor brings down the voltage to something the LED can take. Now, in this particular model, I'm using 3 volts, two AAA batteries, so 1.5 volts apiece. So I'm not sure that resistoring is really necessary here, but it doesn't hurt, and it's a good opportunity to discuss resistors. You can get packs of resistors very cheaply off of Amazon. They virtually, I think, all come from China, and somebody there has gone through the trouble on these packs of literally taping each one and labeling it. So here's just an example of an assortment pack I bought. Very helpful. Probably overkill. I'll probably never use these, or never use the majority of these, but they are not very expensive at all. So it's kind of nice to just have the packs available. I definitely dive into these and use them from all over the place. So I do suggest getting that. And then as far as getting maybe a single pack of something that you would use heavily, I keep a single pack of these 470 ohm resistors because they're the most typical way to bring down your 9 to 12 voltage that we typically use when we power up models, for example, off a 9 volt battery, or 9 or 12 volts off of a plug-in adapter. For those who are interested, here is resistors have a color coding, so you know what is from the color coding. I mean, hopefully someone has kind of labeled them all like those assortments I showed you, but there is some logic. You can take a screenshot or a picture of this little chart I keep pegged up on my workbench, and it'll tell you the color coding on the resistor. You don't have to really worry so much about the ends. That's kind of a percentage of accuracy, etc. It's kind of overkill. And I would tell you this, that there are some variances, but usually there's not variance, at least to those first two numbers, which are the important ones. I mean, like a 470, you would look at the number 4, and the color there is yellow, and 7 is kind of a purple. So you see a yellow, purple, and then you would see one black for the 0. Some I've noticed just do a row of blacks. 0, 0, 0, would be 3 zeros. Some actually follow this, but you can generally figure it out. And the other thing I would suggest to you is, if you don't have one and you are working a lot with electronics, the multimeter has a setting for ohms right there, and you just touch the ends to each side of the resistor, and it'll tell you what that resistor is. So I often have kind of piles of resistors sitting around. I try to tape them up if I'm not using them, so I know what they are, but I can always check either by the color chart or the multimeter. One quick correction: when I said when I was talking about maybe not needing a resistor, what I was talking about was this 270 ohm resistor. It's the one that protects the LED or the SMD. These other two, the 470,000K or the 470K and the 100K, both of those are part of this circuit. They interact with the capacitor to create the effect we're looking for, and so those two are definitely necessary. Probably this 270 is redundant, probably not necessary. Like I said, it hurt to have it in there, so I've gone ahead and included it. But that was the one I was talking about. Finally, we have the capacitor. For purposes of this video, and just because I am not an electronics expert. I mean, I know enough to do a project like this, but I have a hell of a lot of respect for electricians. For starters, the math is just incredible, and that is not my strong point. But again, I can be a monkey. I can learn how to just follow instructions. Basically, the capacitor, absorbs power, as it were, stores it, and then discharges it. And so you can actually make this whole setup, and I'll probably do a following video doing a different type of setup without the chip, just with resistors and capacitors, where it stores up, discharges so that it lights it up, then stops, stores up so the light is off, and then discharges and lights back up. You can do that without a timer chip, just with resistors and capacitors. So again, on Amazon, and I know I keep saying Amazon just because it's so easy to get things off of there. If you have a local electronics store, please definitely use your local store as much as you can. But there are kits available with just a whole range of capacitors. Again, they're super inexpensive, so I think it's worth picking up a kit, and that way you just have what you might need at any given point. For example, on this project, I experimented with a number of different capacitors till I settled on the 4.7 one, because I liked the timing on it. But you can definitely do it with a different capacitor and change the timing that way. When we do our next project and our next video with just capacitor and resistors, I'll probably add what's called a potentiometer, I'm not sure I'm saying that right, into the mix, and that allows you to dial in the speed, as it were. So that's kind of cool. But yeah, for this project, we're going to use this 4.7 UF capacitor. So speaking of kits, when you're working with breadboard, the easiest wire to use is what's called jumper wire. And you can make your own jumper wire, but why? The kits are readily available, you guessed it, Amazon, certainly also at your local electronics store. And somebody's already gone through all the trouble of stripping these wires and making them so easy to use. The kit has assorted sizes. We don't have to use very much on this project. And by the way, it's mostly for breadboard, but it works well. It works just fine, of course, on these boards too, and it just keeps things clean and easy. You could certainly just use regular wire, not pre-made jumper wire for the project too. But I just needed to mention that I would suggest having a kit of jumper wire as part of your setup. If you are not comfortable soldering, you can obviously do this whole project on a breadboard and never have to solder anything. But on the assumption that you're watching this because you either solder or want to begin soldering your projects, you'll obviously need a soldering iron. I use this Weller iron, which is really nice. It allows you to set the temperatures you want, etc. And for the actual solder, I've tried many solders, and this stuff is just fantastic. It's made by Kester. It's you can see on there 63/37.031 solder wire. The 6337 refers to the ratio of lead and tin. And this, if you get it from Kester, it comes like in industrial sizes, but again, on Amazon, people have chopped these down into manageable. I think this is like 10 meters of it or something, in this little tube. It comes coiled up, and it works really well. The heat on your solder iron should be about 350 degrees Celsius, which translates to roughly 700 degrees Fahrenheit. I like personally running a little hotter at about 750 degrees Fahrenheit, but that's just a personal preference. There's a lot of resources on YouTube on soldering, but just quickly on the basics. Make sure every time before you solder, you clean your tip off on your wet piece of sponge. I keep this little copper shavings thing, also knock it on, because undoubtedly a clean tip is the key to soldering. Oh, and I forgot to mention, work in a well ventilated area. Usually I use my airbrush setup that you've already seen on the video, that vents air, vents the stuff out into the outdoors, but it's so noisy that I'm not going to use it for this video. But also when I solder, I use one of these masks, one of these 3M masks. So I probably won't talk much during the next section, or if I do, well, I'm not going to be able to help myself, but it'll probably be muffled. I'll try to kind of pull this off if it's super muffled, but yeah, bear with me. That's because I'm wearing this this mask, as well as I wear my googly eyes on top of that to so I can see. Okay, so I probably sound kind of muffled, sorry, but we're going to start off with the chip, and we're going to start off between this E and F sections, right up on number 1, and remember about the notch. So hopefully you can see, but there's a notch right here, which means that our chip little legs are numbered 1, 2, 3, 4, 5, 6, 7, 8. Oh, and also, I'm not going to use this little guy for this project. It's just, this is a very simple, quick solder job. If something goes wrong with the chip, it's easy to replicate this. So normally I would, but for this project, I'm going to try to keep a low profile since we're crossing those jumper wires on top and just use the chip itself. These helping hands are pretty much indispensable for solder jobs. I've got two different types, the usual type here, and later I'll show this one that I'm using. But we've got all our little legs showing through there. So let's get started. Always tin your solder tip. Tinning just means get a little solder on the tip. Warm up where you're soldering. And then touch the solder to it. Make sure you don't cross between these or you'll get a short. Okay, so let me take this off. So we've done the step here of just putting the chip in. The next step is it's going to be to put these jumper cables, or I guess jumper wires, and they go from pin 8 to pin 4 and pin 2 to pin 6. So we'll start with pin 2 to pin 6. Let me just measure, find out the right size of the wire from that assortment I have, and then we'll come back and get those soldered in. Okay, I'm going to risk my health for you guys and not wear my mask just for today, but always wear your mask. You don't want to be breathing lead in. I'll try to do a little breathing. I've got a window open, although it's horribly cold outside, but I've got a window open. Okay, so our jumper wire, find something to point with here, will, like I said, we'll go from pin 2 to pin 6, which, so this little PCB board that I've got that matches the breadboard is very nice because they've got these letters and numbers along it. So basically from D2 to G3, almost sounds like a bingo game. So again, from D2 to G3. So as you can see here, I've put in a jumper wire into those. Then we'll you know what we'll do is we'll just bend these for right now and put them. So this is a what's called a soldering mat. Takes the solder, heat no problem. So we'll just put it right on our mat and get those guys soldered in. And then we just snip off the excess. So tin your wire, your solder iron, I mean. Wipe off your tip. And then you can just snip off the excess wire. And then we'll do the same from going back to our chart from pin 4 to pin 8, which translates into D4 on our board and G1 on our board. Alright, so let's place that guy. D4 or pin 8. Oh, I need a longer jumper guy. Let's get a red one, not an orange one. Okay. So there's pin 4 to pin 8. Then just bend them over so they'll grab. And let's solder those guys in. Here, I'll zoom in a little bit closer. I'm wiping off my solder tip, run it through the copper wire, the copper shavings a little bit. And a little bit of heat. Oop, tin your solder iron. Well, so your solder iron will go to sleep if you don't use it for a while. So mine's gone to sleep. I just woke it back up, so it's heating back up. So I'll wait. I like this Weller setup. It's got little temperature gauge right in front. I can see it going up. Here we go. Alright, we've gotten there. Let's tin our soldering iron and hit this guy. And this guy. Okay, so we've got our little cross section, and then from here, what I do is I basically just start at the top and work my way down, just soldering in the components. So the first component, after the 555 timer chip and the two jumper wires, will be resist. Here, let me. Well, here I can probably get this onto the camera. Yeah, there we go. Will be the 470K or 470,000 ohm resistor, which will go in these two pegs between I2 and I3. So, and then we'll do the $100,000 ohm resistor between H1 and H2. So let me get those two resistors. Let me get those two and we'll be back. So here's the 470K resistor. I doubt you can see this on the video, but it's got a yellow band and then a purple band, which if you recall my chart, yellow means 4, 7 means, purple means 7, and then it has black and orange. So black means 0 and orange means 3. So this is a little bit different than maybe typical American nomenclature would be. Typically you wouldn't have the black, you would just have the number of zeros in the color. But so the charts are helpful, but you should probably check before you solder anything in. So if I and I just switch hands, it doesn't matter. Resistors have no polarity. It doesn't matter which side is where. And I don't know if you can see my multimeter there, but I'm going to touch to both ends. I've got it set to the ohms, to the resistor setting, and it says 0.482 M. So because resistors are not perfect, they can be, and actually that other band is whether they're within 5% or 10%. For our purposes, it doesn't matter, so I don't really go into that. But I've confirmed that this is a 0.470 M or 1,000, for 470,000 resistor, the one we're looking for. Okay, so we turn that guy off. And this is our resistor that will go. Let me refocus here, make sure we're on camera. That will go between I2 and I3 on our breadboard, or on our PCB board. So I2 and I3, and we'll push that guy in there. And you can bend this side out a little bit so it'll hold in place. And normally I would place the other one too, just for time's sake, but in this case, I'll go ahead and solder this in first and place them separately. Actually, we won't use that helping hand. So let's just use our mat, which can take the heat no problem. So we bend out these guys, put them down on our mat. Wipe off the tip, get it clean. Tin up our tip. Ooh, take a deep breath before tinning. Well, actually, you're wearing your mask, right? Okay, good. Then I clean my tip before putting my soldering iron in its little holder. And we can snip off this excess guy. And then let's do the same exercise for our 100K or 100,000 ohm resistor, which is our next one. Here at H1 and H2, 100,000 resistor. Let's just double check him before we solder him in. Better to know now than later. Hard to do one-handed or two hands, but there we go. I don't know if you can see, but on the multimeter it says 100.7K. So this is our right one. And as I said, it goes between H1 and H2 on our board. Right below and one to the left of the resistor we just did. And again, resistors have no polarity. Chips do, and as we'll see when we get to our capacitor, capacitors have polarity. They have a plus and minus, but resistors don't care. They can go any which way into their proper hole. I crossed over here, but that's okay because all of these guys are on the same line, so it doesn't matter. Where you want to make sure you don't cross is between copper lines, or you'll be subject, well, you will get a short. So anything along the line, no worries. You want connectivity there. So when I clip this guy, here's a little piece left over. It looks like it's heading toward this side. I want to make sure there's no contact with the adjacent line. That would be bad. So, alright, we're clean there, clean here. We'll make sure at the end too, but there we go. Okay, so onward we march. We've finished the top section, and our next one is our 270 ohm resistor, which I've marked here. I've tested this one a number of times, so I I should test it again, shouldn't I? Fine, we'll do that. Better to find out now than later that you put the wrong component in. I would tell you because I built this board before with a 470 ohm resistor on that first one that's supposed to be 470,000 ohm resistor, and my light just lit up and it wouldn't blink. And luckily that was on a breadboard, so I was able to eventually figure out where I'd gone wrong before having to solder something up. But the value of the resistor does, of course, make a huge difference. Okay, so this one's showing 0.268, in other words, 270 ohm. So our 270 ohm resistor goes between D1 and D4. Now this is kind of interesting because it comes out past where our chip is, and that is because that's where the negative of our LED, or really in our case SMD, will be on this row here. Okay, so we're on this row D, which by the way is the same row as the ends of these jumper wires are. So it just bookends those jumper wires. It's on either side of them. Okay, so going to lift him up just a little bit because we're going to use that C row. I don't think it'll interfere at all, but just bend these out. Let's get those guys soldered up. Just noticed I didn't solder in the other end of this jumper wire, so no problem, we'll get them done now. And then the other side of the 270 resistor. Got him in there. Snip off our excess. You want to snip as close as you can, not only just give a good clean appearance, but also to avoid shorts, avoid anything crossing over to where it doesn't belong. Looks like on this jumper wire I left a little extra here, which is gonna come off now. There we go. Okay, so we have all our resistors done, and now we go to our capacitor. Okay, so capacitors, and by the way also LEDs, have a long leg and a short leg. The long leg's the positive, the short leg's the negative. On both capacitors and LEDs, it's very important that the positive go where the positive's supposed to go, and the negative go where the negative is supposed to go. So, in our particular circuit here, you can see that I've marked negative at this C1 part and positive at the C2. That means the short leg of our 4.7 capacitor will go at the C1 and the longer leg will go at the C2. So let's place that. C1 and C2. Make sure short leg, yep, short leg to the left, long leg to the right. Okay. And let's bend those guys out so it'll stay put. And let's get them soldered up. The final step, other than our power, is the actual terminals where the LEDs will go in, or in our case, the SMDs. So one could just wire the two positives of, each of one red, one green, or if you're doing white, true to the show, just both the whites, the positives into B3 and the negatives into B5. I like these screw down terminals, and you guessed it, you can get kits of them off of Amazon, and I'm sure at your local electronics store with assorted screw downs. The two-prong, there's actually a two-prong that works perfectly for this. It's got a positive that goes in here and a negative leg that goes in here. You can see I've pre-pushed that into here. It sits a little bit high because it's hitting that resistor, but it's enough. I can see the legs coming just barely, but coming through here, so no problem. So let me place this on the mat firmly, and we'll come back, solder that terminal in. and then all we'll have left is to apply power, and we'll put a test LED and make sure it all works. Okay, we've got them pushed in there as tight as I'm comfortable with, but I can see the little legs sticking out just a little bit here. Let's tin up our soldering iron. Okay, so we've got everything in place. All we'll need to do, and we'll just do it temporarily now as a test, but we'll apply power to J1, positive power to J1, negative power to A1 through our battery. And all I've done is taken a regular 9-volt battery. Remember, this is already resistored, and put one of these little battery guys. You can, no surprise, you can get them off of Amazon. Actually, I think these actually did go up to our local electronics store and got a packet of these direct from them. Okay, I've screwed in just a generic LED. We've got the positive side here on the left, negative on the right. Then we've got our battery. Our positive goes to J1 over here, and our negative goes to A1 over here. Oh, I pulled him out. Let's get him back in there. There we go. And our light blinks. Bingo. So obviously a couple modifications when we finalize this. It will be the SMDs, 2 negatives going into this side, 2 positives going into the left side, and we'll obviously hardwire in our power so I don't have to sit here and hold it. But as you can see, success. We have our blinking side light and blinking at a speed that I really like. Alright, in our next video we'll start laying down all our static lighting, as it were, or the remainder of our lighting, laying down our SMD strips. I think we'll start probably with the well, I don't know where we'll start. We'll get there, but that'll be our next video. We'll start on our main lighting. Thank you for watching. I hope this was helpful. I hope it was helpful too for other projects. You can see all kinds of applicability for this type of thing. And as I said, I'll also do probably a video coming up on just a different method of getting the same result.